So because of time, we are going to start. So good morning, good afternoon from wherever you are streaming from. This is the East Central and South Africa Microsoft Excel Forum, brought to you by Crisp Excel Training and Consulting. If you wish to support the webinars, you can buy this book. Today, we are privileged to have Stephen, who is an Excel developer. His areas of expertise is developing Excel add-ins, machine learning, and corporate training. And you can follow him on LinkedIn. He has a group on LinkedIn also. And he has some interesting courses on his website, Midas Tech. I'll share this with the participant and the attendees. You can check out his Excel courses, and maybe today he's going to tell us more about his Excel course on flowcharting with Microsoft Excel. And the topic of today is flowchart-based modeling in Excel. So without wasting more time, welcome, Stephen, and you can share more about yourself, and we can continue. Thank you. Stephen?
Just checking that you've got my slides, or I have to reshare it.
No, you have to reshare it, sorry.
Okay.
Yes.
Firstly, I'll just introduce myself. Thanks, Crispo, for organising this meeting. It's really is an honour for me to be able to share this. I'll be going through my slides and explaining a little bit more about myself and just showing some of the software I've created. Just bear in mind, I can't really run it because I've found historically that if I run it while I'm on Microsoft Teams, it'll crash. It's just too much memory, but I will show you as much as I can. So Excel Flows, the name of my software. I've been working on this for about 12 years on and off amongst various other activities. But the basic concept is to do flowchart simulation in Microsoft Excel. And I might add that this isn't a new initiative in the sense that there's others who have done this sort of thing before. But I've created a system which is very general. So just a little bit of my background. Crispo really gave the background in terms of Excel, which is fine. I do actually come from more of an academic background or research background. I've published quite a number of scientific papers, which peer-reviewed and so forth. I've been involved in various commercial mineral processing simulation systems, and I've been involved in various industry-funded research projects. I'll just switch my camera off now. So I worked at the university in Queensland. By the way, I'm from Australia. I'm from Brisbane, Australia. And I'm at a place called Sunshine Coast. I'm 1 block away from the beach. So when I don't work, I enjoy life. But I was involved in quite a number of software, and that included simulation software, flowchart-based simulation software through the university. And then for various reasons, I decided to go independent. Now, I also have a background in mineral processing, engineering. So I have a PhD in engineering. And I wanted to promote a lot of my methods in engineering. And I won't go down talking about that at all, but I'm just highlighting the fact that it was novel mathematics applied in mineral processing called information theory, which is the foundation of specific machine learning approach. Now, I advocated a particular type of strategy, and that led to me giving courses in simulation. And then just this slide is just indicating the fact that this talk is about Excel, simulated from an Excel perspective, not so much from mineral processing. However, I get most traction from mineral processing because that's where I come from. But the simulator I've developed is for anything that can be described by a flow sheet. And I use the words flowchart and flow sheet interchangeably. Flow charting is the more generic term. Flow sheeting is what a mineral processor understands. You'll see a mineral processing flow sheet so that you'll get context. Now, the Excel concepts which are essential to this software are, of course, flow charting, using templates and cell styles. And then there's a list of highly desirable skills, such as using name ranges and arrays. And also the use of VBA and understanding the ribbon framework. Now, we're not going to go into any form of depth on these topics. I'm simply providing the fact that this is the skills that make up using this flowsheet system. But there are various types of users, but the predominant number of users need to know these three skills: how to create a template, how to use cell styles, and flowcharting. And you will see this as we go. So I just want to explain what is meant by a model or a unit model. So a unit model has an input, it might have parameters, and then it has an output. If you're using Excel and you can't describe something as an input and an output and parameters, then I would not call it a model. I might call it just a calculation set, but it's not a model. And it's actually quite confusing because unless you know what a model is, you're not going to understand flowsheet modeling. So basically, each shape represents some form of model. Now, the whole basis of this approach is the idea of a template. So for a particular type of unit, so in mineral processing, that might be a cyclone, you create a template. That template has to be copyable to be applied to different cyclones. And so they form different instances of the same unit model. If you understand that, then it becomes quite easy to understand how the system works. So we combine unit models together and we create a flow sheet. So this is a flow sheet. I'm going to go through it a little bit, and I'm not sure the background that the participants are coming from. I'm presuming it's not mineral processing, but I'm hopeful that you're familiar with the idea of a flow sheet. Now, I'm going to dwell on this for about 5 minutes because otherwise it's going to be, the rest of the seminar is going to be confusing. And if you have questions, Crispo will let me know. He'll probably stop me and then ask the question. So feel free to ask questions, particularly if you don't follow what I'm saying. So
yeah, you can type them on the chat, or you can raise your hand. I'll give you a chance to ask.
yes. So
Okay.
if we have a unit model for a ball mill, a unit model for a cyclone, a unit model for a flotation cell, and I'll talk about these red and blue ones in a minute, then we just create a flow sheet in Excel. And in that way, once those models are created, we're creating the simulation system. So it's called visual modeling. And visual modeling has been around for a long time, probably about 70 years. But the idea of using it in Excel is novel, but as I said before, there are others who have done it. I was largely inspired by a guy named David Wiseman, who created the LIMN system, LIMN, and he was actually an associate in my mineral processing. He moved away from proprietary flowsheet systems and wanted to do something in Excel. Now, I might mention him later, but he was very successful. And the difference between his approach and mine is I wanted to create a system that could be applied to any process. So I'll get to that as we go. Now, I'll just explain these red and blues and also these triangles. So I'll just explain what's actually happening. This is the feed, and it goes to this red circle unit. And that joins whatever is coming from the cyclone with this feed and creates this stream here, which is the feed to this unit, which is a ball mill. Particles are broken into smaller sizes. And this is the product from the ball mill. And that goes to this cyclone, and that separates particles according to their size. Now, this type of modeling has been around for about 50 years in various other software. So it's not new, this concept at all. So it's just the idea of putting it in Excel, which is distinct. Now, for those of you who are really astute, you would have noticed that if I'm doing this type of process, then I've got information going round and round. And this is a recirculation, which if you set up equations in Excel or formulas, you're going to get circular references. And that's going to, Excel can't handle, nor should it handle, circular references. So what happens is the fact that these red circles tell me that it's not only are we joining streams together, connectors together, but we're going to have to stop the calculation here and do that later. Not through using Excel formulas, but directly through a VBA type process where we just connect these two streams together to create that. Now, I've already introduced a few concepts I need to clarify. In terms of flow sheeting, Excel would call, or at least I'm going to call this a shape or an icon. So you can bring in these images yourself or you can bring in shapes from Excel. Now, I don't really want to explain how to create a flow sheet. That is the topic of one of my Udemy courses, which goes for about 20 minutes, and actually a couple of hours. So we would bog down if I try to explain how to do flow sheets. So you just have to visually see what's the outcome of doing that. Now, this, in terms of Excel, is called a connector. But what it's representing in terms of mineral processing is a stream. So I'll interchangeably use those two terms. And if it doesn't make sense if I'm talking about mineral processing to call this a connector, so I call it a stream. But if I'm talking about it as a flow sheet system, then I should probably try and use the word connector. So as Crispo has asked me whether or not you can get some sort of discount to the Udemy courses related to this seminar, and the answer is yes. You can either, I think we haven't identified the best process, but the principle is there. So if you wanted discounted coupons to any of my Udemy courses, then you can write to Crispo or write to me. Now, I just want to also clarify why I'm here. that flow sheeting is really an essential skill if you're a professional Excel developer. Now, this is a breakaway from many of the conventional lessons that are being taught in Excel for reasons I cannot understand. But one of my strong emphasis is that if you have complex Excel workbooks, you need to create data flow diagrams using flow sheets. So even if you're not using the simulator, flow sheeting is very important. Now I'll move on. So if we have the unit models for all of this and we've done a flow sheet, then we've actually created the background for the simulator. So Excel Flow converts Excel from being a spreadsheet system to a visual modeling system. Now I'm hoping at this point you're all with me. If not, please ask a question because I don't want you to get left behind. And I'm not getting Crispo interrupt me, so I'm presuming you're all with me. Now,
Yeah, there's no question so far.
So, as I mentioned, this is not specifically unique. Dave Wiseman Lim developed it, very successful. Hundreds of licenses. And when I'm saying hundreds of licenses, I'm saying at pretty substantial costs. And like in the Australian mining industry, for coal, there would not be one coal plant in Australia which does not use his system. In other words, he's got 100% market share. He also has a good share in iron and diamond plants. I was actually going to work with him, but when it came to some of the strategic concepts by which you model, there was a divergence, and in time it seemed better for me to develop my own system. Now, my system hasn't received huge market acceptance. I'll say that straight out. Where I do get interest is giving courses. So I give courses in simulation, largely in the mineral processing space. I teach Excel, those skills plus other fundamental skills of Excel. And people like to go to those courses for the mining industry. They like to see the simulator work. The idea is to apply the simulator to real mineral processing plants. The issue is getting the right data from the plants to apply the model. And that's going to go on this discussion of mineral processing, which I'm trying to avoid, and I'll try and pull back if I get down there. So I also want to mention another product called Visio. Now, I'm not sure how many of you have seen Visio, but it's another Microsoft product, not originally developed by Microsoft, but it now is Microsoft branded, and it's a flowchart system. And I thought originally that I would use Visio. And I'm just sort of preempting in case any of you were sort of wondering why aren't I using Visio? Because Visio is actually better than Excel. When you actually try to do the connections and shapes and so forth, Visio is much more easy to use and more powerful. But what I discovered giving courses is that all mineral processors use Excel, and only about 5% were aware of Visio. And so I just found that if I gave the courses and this flowsheet system using Excel, people understood what I was saying, whereas Visio would create layers of installing software and getting used to a new product. But what is particularly useful to know is that Excel Flow uses VBA, as does Visio, and you can communicate between the two systems very effectively. Now, that's higher level forms of using Excel, which is a bit beyond this seminar. Perhaps Crispo might want to invite me to discuss this sort of thing later. But basically, you can connect Excel with most of the Microsoft products, such as Visio, Microsoft Access, even SQL Server, Microsoft Word, and even PowerPoint. For those, most common I do is connecting Excel Flow with Microsoft Access. So that was, and now there's two things I probably have glossed over. I'll just recap a little bit. You may not have the flowchart system on Excel. You may not see it. And I'm just going to briefly show you. So I'm going to stop sharing and just show you Excel quickly. As I said, I don't want to bog down, but if you look here, you'll see that, sorry, I have to share again. If you go File, Options, Customize Ribbon, you'll see a tab here for Insert, and it should have shapes. I've probably jumped too far. But you'll also have a Developer tab for VBA. I'm just going to close that. So if you go Insert, you'll see you've got the shapes. Now, we're not going to run through it, but that's icons and so forth. And I also have a trick where I put them all onto a frame, which I won't go into here, but it means that I can grab all the shapes and treat them as a single object. Now I'll go back to the main slides. But this here, this PowerPoint shows what I've created. Sorry, this Excel shows you what I've created in Excel. So back to it. So that's all I want to discuss about Excel. But bear in mind, if you are particularly used to Visio, sorry, that's all I want to discuss about Visio. If you particularly want to see this adapted to Visio, then that's easily done. It's quite straightforward. So the characteristics of Excel Flow, as I said, I wanted to create a system which wasn't just mineral processing. So you create a template. I will show you an template so you've got an idea what I mean. It's created directly using what I call front-end Excel. You can add VBA as you see the need. And just to re-emphasize, VBA is Visual Basic for Applications. It's a language within Excel. It's free, and it allows integration between Excel and other Microsoft products, and it actually allows integration with other types of software systems as well. So templates can use VBA. It's not essential. So design it for any system. I've had some inquiries from non-mineral processors, but most interest is in mineral processing, particularly as I give courses in mineral processing. But it's basically can be used wherever you can map your process, describe your process with a flow sheet. So civil engineering, river flow, pipe flow, transport systems, electrical engineering, electrical circuits, business process modeling, and financial modeling. Bearing in mind, there are in fact other software that exists in financial modeling. I don't really know the details. I looked at them at one point, but they're also flow sheet based. And as far as I can tell, quite successful. So here's just a simple example of an electrical engineering circuit. We're not going to go through it, but to sort of show you the concept. Anything that can be described by a flow sheet can be applied using this system. And obviously, I want to try and link up with anybody who might have a particular application, a domain. To give an example, so this Excel Flow is not part of a Udemy course at this stage. So the Udemy courses are sort of like the introductions, the skill sets necessary to later use Excel Flow. So there's various types of users of this Excel Flow. There's the person who develops the entire system, which is myself. I haven't linked up with anyone at this stage. I'm happy to discuss linking up with appropriate people. But then the next level is a domain expert. So if you could be an electrical engineer. I don't know what you people do. You might be an electrical engineer and you might say, hey, I want to convert Excel Flow to deal with electrical engineering systems. Well, I would call you a domain expert. I'm not the domain expert, you are. You need to either get or create the icons, create the templates for the unit models, and match those unit models to the icons. And I provide guidance on how to do it. But I'm not the person to create those models unless you can lay it out for me so that I can do it. Then we have the application expert. That's lower down. There's someone who's given a domain, creates appropriate flow sheets. So I want to talk in the mineral processing space because that's where I'm from, and I'll get confused if I try and talk about other domains. But a consultant in mineral processing will say, hey, I want to use Excel Flow for mineral processing. For this particular mineral processing plant, I need to create the flow sheet for this plant and give you information about the units. They're an application expert. And then there's the end user. Here's the person who's given the application and he just tries different scenarios. What happens if I change the feed? What happens if I change the way I run a mill? And most people want to be end users. So when I get inquiries, most people say, I want to use it for mineral processing. I just want you to create it for me for a flow sheet. And I just want to be able to determine what happens when the ore changes or if I run the plant differently. So stages of Excel Flow, there's the domain expert, he creates the templates and the icons. Application expert, he creates a flow sheet. And then there's the person who just runs Excel Flow for a particular scenario. Now, Excel Flow, I actually went away from the idea of like a single command button does everything type thing. Instead, there's various steps. And I'll just explain the steps for mineral processing. And I presume templates and flow sheets are already created. So we configure the process. We just say, what's the flow sheet? Where do I find the templates? Which file is the output? Configuration is straightforward, but once you've configured it, you can run this over and over again. It then processes the flow sheet. So before I explain that, no, I'll explain the whole lot and then I'll go over it. Read and process the flow sheet. It then copies the templates for each connector and unit to create worksheets for each unit connector. Now these largely are Excel equations. So they're copied and applied to different units. You have to input the relevant data, preferably from a database so it's automated. And then it adjusts the copied templates. You don't do it, the system does, so that inputs and outputs are as in the flow sheet. And then there's recycles and joins. I have mentioned the recycles. The joins are the blue, which in that case is just saying this plus that equals that. It's very straightforward. And that was one of the differences between Excel and Visio. in Visio, you don't really need these blue icons, but I was surprised mineral processors are pretty happy with the idea of just using joins because they can understand the flow sheet better. As I said, I've developed a strategy to deal with recycles or circular equations. I'll stop there and just I just want to go back and just say, yeah, read and process the flow sheet. I'll just explain what that means. So here we have the flow sheet, and processing the flow sheet means finding out the relationships between the streams or connectors and the units. So for this particular unit, what is going into it, what is coming out of it. Now remember, the way the system's more flexible than I'm saying. I'm just keeping it to simple application. So there's a worksheet that's completely dedicated to this stream. There's a worksheet dedicated to this unit, and there's a worksheet dedicated to this, and so forth. So again, I'll just share the screen and get an idea of what I mean. I'll share Excel. You can see here, this is just the head. This is a connector. This is the this is a stream or a connector, and it's a dedicated worksheet. I'm not going to dwell on it too much, but it's using Excel, simple Excel. That's a VBA function, but Excel to basically work out what's going on in the connector. This is all set in templates. I'll just quickly show you what I mean by a template without going over it in detail. So classifier is that cyclone. If I say classified template, I know that there's lots of division by zeros here. Don't worry about it. But basically, I set up a whole host of equations here. We say if I knew what the feed was, I know what the corresponding product is. Now, as I said, if I start making too many changes, Excel will crash with using Teams. But if you look here, over here, I have the relationships between units, between the streams and the unit. So I say, what is the connector going in? And it turns out it's a dummy stream called connector template. But I could change that to plant feed, and then manually, well, not sort of semi-manually, I could just say, go to home, find and replace, find, select, replace, and replace connector template with the actual true stream that's going in. And that's would basically change this here to be plant feed. So basically this is all copied all over, and that's basically a step, is to copy these templates to create worksheets. And those worksheets are, as I showed before, there's quite a lot, but they're all linked by largely by Excel formula. And so there's a stage which basically says, okay, change the what you've got as the input and the output for each stream, for each unit, and replace it with the real one. And so that just replaces it here and does a replace throughout the whole unit or connector. And that's it. That's actually the simulator. So the simulator is quite simple in concept. It's just automating all the equations based on the flow sheet. So that's largely the integration. I'll go back to the PowerPoint. Yeah. The as I said, if there were no red recycles at all, that would be the end of the creation of the simulation. That's it. Because if I change the feed, it will predict all the downward streams. Because there's recycles, it will stop here and it won't update there. And then I just run a simple VBA command which says update this based on that and do it for each of them. And it runs about 20 times, iterates, and eventually you get a new con and a new tail. I didn't really explain what these triangles were. They're just visual to me. They tell me the endpoints. So the beginning and the end. So simplification, right, I create this pretty complex spreadsheet. Okay, I've got the templates attached and the user doesn't want to see any of these templates. They just want the outcome. So that's the next step is simplification, where I just remove I rename it and I remove all the stuff the user doesn't want to see. And then the next step is to create a dashboard, which is just, I'll see if I could, might be a bit ambitious to load it, but it's a single worksheet only connected to this. It's part of that workbook where the user can make a simple change, run it and see the change. So there's different levels here. And I might add, it's only recently I realized I have to do this. And the dashboard makes the system much more friendly to the end user. And basically, the people I talk to, I was originally hoping to talk to domain experts, but the reality is I'm talking mainly to end users in mineral processing. They just want to see a simple dashboard at the end, and then they're happy. So I'm trying to round off the talk now. So where is Excel Flow heading? Well, there's definitely active interest in mineral processing, but I'm not going to be able to retire on it. So I get to do courses a few times a year in it. And so it's called Simulation and Optimization of Mineral Processing. And these are direct courses to the industry. And I also have a particular type of application of this simulator called mass balancing. Again, I won't dwell on it, but I get interested in that. I've had interest in other subject areas, but no real uptake. And I've had various attempts at commercialization, approaching investor groups and so forth. I would say that hasn't been successful. So it's not been particularly lucrative, but it exists and I'm developing it as I get interest. So this is where I'm heading, my company. Midas Tech is my company, and Midas means Mining Industry Data Analytics Service. And this is a sort of it's supposed to represent a complex ore particle and mineral processing. I give direct courses and I develop software. I meant to say also Udemy courses, but of the direct courses, they branch out into teaching Excel and teaching mineral processing. And the software is mineral processing, but I'm really looking for other applications beyond mineral processing. I might just round up and just explain a bit more about the Excel courses without over pitching it. I was giving courses I'll actually go do teams, make it a little bit more personable, showing the camera. I started off giving courses in mineral processing and simulation. I was giving examples of unit models, and then I discovered that the participants often didn't know how to use Excel to a high level of proficiency. I also discovered that they were using Excel a lot for multi-million-dollar decisions. So that indicated to me there'd be a need for giving Excel courses. And I also recognized the fact that the people I spoke to, mineral processors or people from the mining industry, they could handle flowsheet diagrams. Once you explain to them, look, you've got a complex workbook, let's draw a diagram about it and treat it like it's a flow sheet. They go, oh yeah, that's a good idea. And funnily enough, they never really thought of it. And so I developed this strategy of how to deal with Excel. I provide courses in Excel, and that's where I get most interest. So a lot of activities, but main breadwinner is in fact teaching Excel to the mining industry. So I'll just see if that's the end. Oh yeah, if you want to be a domain expert, now if you want to be an end user, that's fine if you're already a mineral processor. If you want to be an end user in chemical engineering, I do not have the models. So I'm really looking for domain experts. But if you want to be a domain expert, then these are the skills I said at the start you probably need: flow charting or flow sheeting, creating templates. I'll just explain cell styles a bit more before we call it a wrap. I heavily use name ranges and arrays, and I've tried to avoid VBA, but a lot of what goes on behind the scenes is VBA, and it's good to have an understanding of the ribbon framework. And I'm just going to show that template again. That's how every cell style is colored. So there's a color everywhere. I don't use this. I use home cell styles.
Maybe you can share your Excel sheet, Stephen.
Sorry. Thank you.
Yeah.
No, it's all right. So, yeah, here in this template, everything is colored. And I don't use this. I avoid the fill color like the plague. I use cell styles, which is over here. And I have a list of my own cell styles, but everything has meaning. And it's also useful sometimes when I'm copying information to know the cell style. So that's an essential skill. I'm going to say it's an essential skill for Excel. It's one that's for some reason not taught. So these are all essential skills in Excel. And I just can't understand why anyone wouldn't go down the path of name ranges. I avoid A1 notation like the plague. Everything here is using name ranges. And in order to use name ranges and arrays, you really need to use at least some VBA. The ribbon framework, if you notice up here, so this ribbon is for analysing a flow sheet. So, and this one is actually the setting up the model. I'm just going to quickly do it, and if Excel crashes, that should be okay because it's late in the seminar anyway. So I say set. It didn't like it. So I was right in saying I shouldn't do it. I'll just try it again once more just to prove it. No, it just doesn't like it at all. Yeah, so I'll get out of that. and go back to PowerPoint. PowerPoint, share screen. So Teams, stop sharing. Microsoft Teams. Yeah, look, I've gone through the talk. If you're anyone's, there's a video on excelflow.net which goes through the process of running the software. That's actually about 2 years old, so it's a bit different now. But we're trying to aim to create a new video in the next week. If you're really actively interested, please write to me. You can start off with LinkedIn at Stephen Raywood. I do have a group that Janet will send emails to. Janet's behind me. She works with me on the Udemy courses. And we keep you up to date with what we're doing. And also I have a newsletter in Excel where I talk about some Excel methods, but generally I keep it to the idea of using Excel as a process modeling system. I'm not interested in how to wrap text or how to do a border. It's more on that theme. So if there's any questions, now would really be a good time because I've finished.
Thank you for the presentation, Stephen. My question is, and I think this will apply to many of the attendees, not many are in mineral processing. What if you want to make a Excel flow sheet for a financial process? How would you go about it?
Yeah, thanks
Where
for
would
that.
you start? Where would you start? How would let's say that you are yeah.
So I'll just go back to sharing the screen, but I'll just it'll take about 5 minutes to answer, and I think that's okay. So I'll just go back to Teams. Look, it's I did ruin my Excel connectivity. I can't find Excel, so I'll just discuss it. So
Okay.
if for a start, you need to do that course on flowcharting in Excel. There's various tips on how to do it, but if you can describe your process by a flow sheet, then you're halfway there, really.
Okay.
And then basically you need to then look at each particular shape or icon that you put into a flow sheet, and you say, as I said earlier, I'll just do it right at the start. So you've got some shape. You need to be able to say, for that shape, what is the input or the structure of the connectors? Identify what the structure of the connectors is going to be. Now that for mineral processing, I didn't really show you briefly, but it's solid flow, assay, size distributions, things like that. And so the data structure should, in most instances, stay the same for each particular stream. If they don't, that's more depth than what's covered in this particular seminar. But for input going into the unit model, you've got to be able to predict the output. So you have to create this template. So you apply it to some input just to check that you've got it. And parameters are things you can adjust and control. I would say that it would take about a 6-hour course to explain how to do this if you're already a domain expert. But as I said, I'm not the domain expert, so I can't tell you what the unit model is. You would have to be able to at least describe the unit model mathematically or in Excel using simple Excel equations. If you've done that, then that becomes the basis of a template. Now you're 90% of the way through, and then you just go into it. It's basically finished. You go into Excel, it will create the whole system for you, but then you might actually have to say what the original input is, and what your parameters are. And then you would have to design your own dashboard for an end user, which would show what they can control easily. So it would be about, half a day dedicated hard work to explain how to do it if you've already got the skills, which I've already alluded to, flow charting, understand cell styles, understand name ranges. You do need to have some VBA, but that would be covered in my course on name ranges and arrays. And then it would be about a 5-hour course to explain how to actually construct it. So I do tell some people who've expressed interest in other applications, just create one unit model. Just do it the best you can. And then I'll have a look at it and determine whether it satisfies the requirements of a unit model. And if you've done that, I'll help you with your next and next. But you should be able to, once you've done it once, it should be easy to do again and again for different types of units. Okay. I hope that answers your question.
Yeah, in a way. So
in a way.
Excel, in a way, your Excel flow add-in, so it's adaptable to any process.
Any process that can be described by a flow sheet. So as I said, you have to be able to describe your process by a flow sheet.
Yeah, we have Michael. I know he is in finance, so he has a question for you. So Michael, you can ask the question.
Thank you, Crispo. I think this is a unique presentation today. I'm happy for the presentation. And there's something definitely here new to learn. And that is the kind of what the intention of this thing is, at least to give us something new in terms of developing maybe a tool that one can play around to and to help other users or even clients. So my question is, so where do we get this? You said in Udemy you have some training. So does it cover almost the whole range of what one can, after that, can easily come out and say, I'm prepared to do this? And again, you talked of domain user. Who is a domain user? Thank you.
Right. So thanks for the question. Crispo, you're the one with the courses. The courses don't go into the level of actually teaching you how to run Excel Flow. They teach you the skills required to later use Excel Flow. My problem is I'm not getting much demand for my courses, and it's a lot of work. You have no idea how much work it is. And so it hasn't become a high priority. But in terms of what you, Crispo asked before, may I say the first step is actually, if you have a workbook, is to be able to describe it by a flow sheet. So that's what I get people to do in my courses. I take just a simple problem and get them to draw flow sheets. If you can create a flow sheet from a workbook, that's really the first step. and then you might be able to see common patterns. What you're looking for is the fact that you might be doing the same sets of calculations over and over again, and I would call that manual rather than automatic. So don't necessarily set off a target of creating a flow sheet system such as I've developed here, but simply creating a flow sheet of a process. And again, I'm happy to help with that because from my viewpoint, simple applications like that, I would go in and I'd say to you, well, can we put that into a Udemy course as a lecture? And you get some kudos from that. And it also adds to the practical application of the approach. So that's the first step. The domain expert really is someone who can create unit models. I can't define it any other way. So they could confidently say, hey, I'm working the food industry, food processing. We have some machine which does this. The inputs going into it are this, the outputs are that. And I've set up a model in Excel to describe this process, but you're now a domain expert. You know your domain. I can take what you've done, or you can do it yourself, and I can put it into the flowsheet system. So it's the same. I had a person work for me who was an electrical engineer. I said, you're the domain expert. You tell me what this particular electrical device does, describe it mathematically, and create an Excel spreadsheet that describes that model. He is a domain expert. That's my definition. I hope that is clear.
Very clear. Thank you.
Okay. Yeah, anyone else with a question? My other question is that you have insisted use of named ranges as a required skill in Excel. Why are you insisting so much on named ranges, and why are they important to know how to use?
Well, thank you for that question. It's a very good question. I give courses, for a start, I'm a mathematician. My mindset is mathematics, formulas. I have equations which a symbol represents something. G is gravity. I don't say multiply this equation by 9.86. I multiply this equation by gravity. So if you use name ranges, everything has a meaning. I have feed is a name range, output is a name range, breakage rate is a name range. If I didn't do any of that, it becomes quite confusing to actually understand what's going on. Now, I also found, I'll do this for about 20 seconds, I hope it works. I teach engineers, and engineers are generally regarded as pretty smart people. I teach engineers how to use formula referencing, relative referencing, the dollar sign, so forth. I give them equations to create, and they will take hours. Simple problems take them hours. They don't like the dollar sign. Then I say, all right, now we're going to do it with name ranges. Takes same problem, 5 minutes. Then I have to suffer the abuse, and they go, why did you bother teaching us using cells, A1 notation? You just wasted our time. I go, I had to teach you so you knew the benefits of using name ranges. Now, and then they're happy. For the rest of the course, I teach name ranges. It fits in well with pivot tables, linking up with databases and so forth. And everything makes sense from there on. And you're also treating data as a block of data rather than cell by cell. So again, I was with a company. They said, Stephen, would you mind helping us on a very simple problem? Take you 5 minutes. Just find the problem with this spreadsheet. 3 hours later, I said, do you realize that this particular cell, you've changed the equation? It's not the same as the cell next to it. You've actually said equals 0. Oh, that's because when we set it up, it did equal 0. But I said, but now it doesn't. And you have to go through each particular cell to try and find an error. Whereas if you use name ranges, you're applying it to a block of data. And your chances of making errors has reduced by 90%. So that's a huge advantage. But the other thing to bear in mind is that Excel doesn't like itself. Microsoft does not like Excel. It's a really weird concept. But when I looked at name ranges, I thought this is great, really powerful. And then I discovered, firstly, financial people don't like it. And that's why I don't teach financial people. I couldn't believe that they didn't like it, and I'm not going down that battle. Engineers love it. Engineers, scientists love it. There's a cognitive thing. It's why they love flow sheets. They connect straight away. Financial people don't really get flow sheets. It's a different mindset, and I call it arithmetic type of approach versus mathematical approach. But if you look at the way Excel was created, they didn't finish the job. They just haven't made name ranges as powerful as it should be. And that turns a lot of people off. So I've created my own add-ins to make name ranges more powerful. Having said that, I'm the one who mainly uses it, not so much other people. So, but it fits in well with my flowchart simulator.
Okay. Any other one? Anyone else with a question? So my last question would be, I always ask this to the presenters, is for someone looking up to you and they would like to be an Excel developer, what are the steps that you would encourage them to follow, or how did you become an Excel developer?
Well, I was self-taught.
Okay.
And I made every error you can possibly think of, but I had an objective. And so I would learn the hard way. And groups such as Excel and VBA users, and my own group, Excel Process Modeling, I would ask questions. And what I discovered was that in LinkedIn, people like to help, but you have to ask the questions properly. So there's a skill in being able to ask questions. And surprisingly, I've told this to numerous people, and I find very few people still like to get the help of people in LinkedIn. But that's a huge shortcut. I do recommend, look, I give a 5-day course. I give it to the mining industry. I'm not going to plug it too much, but I taught one guy just something simple, how to use the indirect function. And his reaction was, had I known that, it would have saved me 3 months' work. So self-taught isn't necessarily the best way, because you can be doing things inefficiently and you may not even be aware of it. So, so obviously I advocate doing my course to people in the mining industry or to others, because you're going to, and it's very important if you're working in Excel a lot. So the group I work with, they use Excel 90% of the time. They make major business decisions using Excel. But I would say the skill that I found most useful was drawing a flow sheet of an existing workbook. And that's the skill I start with in my courses. And that really helps people to think about the layout of Excel, whether things are efficient or automated. And if you want to read books, anything by Walkenbach is extremely good. Okay. Excel for Dummies is a really good start, which I think is carried on with VBA for Dummies. And then if you want some really good reading, it's about a 300-page book, which is Power Programming in Excel by Walkenbach. And if you can give yourself a month or 2 months, you can read the whole thing, but there is so much knowledge in it. It's unbelievable. Excel, like even when I give a 5-day course, I say you'd be lucky if I've taught 1% of what's available in Excel. But I've taught you what you will probably most need. but there is so much that you can use in Excel that self-taught is just far too slow. Better to have an objective. And if you've got a good boss, and a lot of people don't, but if you do have a good boss, have an objective in going to a training course. Say, if I learn Excel, I will be able to do this group of tasks much better. And your boss should say yes, because he doesn't want to waste money. You're doing things which are taking too much time.
Okay, good advice. Anyone else with a question before we close? We are past the 1 hour. I don't think there's any other questions. Stephen, thank you for the presentation. I will share your email and your LinkedIn profile so that people can reach out to you. Also for the discounts that you have promised, so that people can also get a bit of discount and learn how to use name ranges and sell styles. I've never used sales styles in my life. I'm ashamed to say that. Maybe I'll get a discount for your course to learn how to use sales styles.
Well, yeah, I mean, sorry, just if I were to recap on people who come to my course and actually say, well, how much have you used previously? Yeah, they wouldn't have used much previously at all. So people are missing out a lot by just doing things self-taught. So yeah, thanks for that. There was something else I had to say, I've forgotten. So keep going. Yep, send me emails to those who want to be kept informed.
Yes, I'll do that. And anything else to add before we close?
I'd just like to say thank you very much to CRISPO. This is really great that you organise this, and I wish all the best to all of the participants. And maybe there might be something I can show in a year's time or so.
Okay, thank you for coming, and talk soon.
Oh, yes,
Bye.
the last thing. If you do a Udemy course, it really means a lot to me if you give it a good review and good rating. I'm not supposed to say that, but it's true, and it makes a huge difference.
Yeah.
So please think about being generous.
Okay.
Yeah, an honest, great review would be really wonderful.
Okay.